So this is a National 4, National 5 lesson. It's Unit 1 and we're looking at rates of reaction. And today the focus of our lesson will be on calculating the rate of reaction. So looking for a numerical answer. So we'll learn how to calculate the rate of a chemical reaction and the average rate of reaction. We will present experimental results as graphs and be able to calculate the rate of reaction from graphs and also from tables. Now, the main equation that you need to know whenever you're calculating the rate of a reaction from a graph or from a table is that the rate of reaction is defined as the change in the amount of reactants or products per unit time. And this can be simplified to rate of reaction is equal to change in quantity divided by change in time. And what we mean by quantity, well, that could be the mass of reactants, it could be the volume of a gas, it could be the pressure of a gas, it could be the intensity of a color. Anything that can be measured counts as a quantity. The main ones, however, are volume of gas and mass of reactants. So here we have a graph. How can the rate be calculated from a graph? Well, firstly, we would only ever calculate the rate of a reaction during the part of the graph where it is diagonal. So the first part of the graph where it's a straight line and it's going up. So the gradient, that means the steepness of the graph, is equal to the initial rate of reaction. Rate of reaction is change in quantity divided by change in time. So if we go along to 20 seconds, that is the amount of time that's passed. So from the start of the reaction to 20 seconds, the change in time is 20 seconds. If we go up from 20 seconds to the graph, to the line, and then across from our graph line to the y-axis, we can see that about 45 centimeters cubed of gas has been produced in that amount of time. So our change in quantity is going to be 45 because we started with nothing, we now have 45, so the quantity has changed by 45. So the rate of reaction is 45 divided by 20, which is 2.25 centimeters cubed per second. Now the units for the rate of reaction will always be something different, but it's always the units for the thing on the y-axis for the quantity divided by the units for the x-axis, the time. So in this case, our quantity was a volume of gas in centimeters cubed and our time was in seconds. So our units were centimeters cubed per second. So this is a second example, and this time it's calculate the rate of reaction for the first 30 seconds of this different experiment. So what we do is we go to 30 seconds along the bottom, we go up to our graph line, and then we go across to our line that tells us about volume. So we can see that at a time of 30 seconds, the volume produced was 45 centimeters cubed. Rate is change in quantity divided by change in time. So that is going to be 45 divided by 30, which gives us 1.5. And again, the units are the units for the volume for the quantity, which was centimeters cubed, divided by the units for the time, which was seconds. So 1.5 centimeters cubed per second. Now, sometimes you're not given a graph, sometimes you're just given a sentence that explains what went on in the experiment. And the equation is always going to be the same as before. So here it says 60 centimeters cubed of gas was collected in 30 seconds. Calculate the average rate of reaction. Now the average rate of reaction is the change in quantity divided by the change in time. So if you ever see a triangle written in chemistry, that just means change. So change in quantity divided by change in time. Now the quantity of gas was 60, the time was 30. So your average rate is 60 divided by 30, which works out at 2 centimeters cubed per second. So if you're ever stuck about which number to divide by which, just remember that the number that is time is always the one on the bottom. So 60 divided by 30 seconds just gives us a rate of 2. So this time we've got a table, and this time we've got it a bit more complicated because we're told to work out the average rate between 2 times. So whenever we're doing this, we need to look at what has changed in terms of time and what has changed in terms of measurement. So the average rate is the change in quantity divided by the change in time. Now our change in quantity. Now for this, we're looking at the time 10 minutes and we're looking at the time 20 minutes. We always go for whichever one was the bigger number, so 20. And if we look at the quantity at 20 in the table, it is 2.2. If we go along to time is 10, the quantity is 1.2. So our change in quantity is going to be 2.2 minus 1.2. Our change in time is just going to be the larger number for time minus the smaller number for time. So 20 minus 10. And so if we do that, we end up, it's going to be 1 divided by 10, which is 0.1 bar per minute. You can see that the units are different, and that's because the units in the table were different compared to the graphs we'd looked at previously. So you're hopefully now able to read information off graphs and calculate rate of reaction from graphs and tables. What's going to come next are a series of past paper questions. And there's quite a few of these, and that's because calculating a rate is a really important skill, and you can see that it gets asked a lot and in lots of different ways. So this is hopefully to get you some experience so that when you are ever asked questions on rates of reaction, you are fully prepared for it. So we have a statement here. In a reaction, 60 centimeters cubed of hydrogen gas was collected in 20 seconds. What is the average rate of reaction in centimeters per second over this time? So which one of those? If you're going to calculate the rate, is it going to be 60 divided by 20? Is it going to be 20 divided by 60? 1 divided by 60 or 1 divided by 20? Well, the answer is 60 divided by 20, because remember it is quantity divided by time. So that's 60 is the quantity of gas, 20 is the amount of time. So for this one, you're told that 5 grams of calcium carbonate was added to 50 centimeters cubed of dilute hydrochloric acid. The volume of carbon dioxide produced was noted every 10 seconds until the reaction was complete. And this graph shows the data that was plotted from that. Now the question that you're asked is to calculate the average rate of reaction for the first 15 seconds. So it might be difficult to do this off a screen if you're watching the video. But after 15 seconds, we go up from 15 to meet our graph line, and then we go across from our graph to our line for volume. And we see that the volume is about 23, I apologize. So that's 23 divided by 15, remember, quantity divided by time, and that gives us a value of 1.53 for the rate. The units would be centimeters cubed per second. So we've got another graph, and it's telling us to work out the average rate between 0 and 20 seconds. Now, if we do that, if we go to 20 seconds and we go up to the graph, and then from the graph we go along to our volume of oxygen, we can see that it's going to be 29 divided by 20, which gives us a value of 1.45 for our rate. So this is one of the more complicated examples you can get because we've been given a table to work out our rate from, but also because we've been given two different times and we're working out the rate between those times. Now the equation we're going to use is exactly the same as before. It's going to be change in quantity divided by change in time. Now the two times we were given were 30 seconds and 10 seconds. So we need to use the table to find out what the quantities were at each of those times. Now at 30 seconds, the quantity is 29. That's the volume, it's 29. At 10 seconds, the quantity was 12. So the change in quantity is going to be 29 minus 12, which is 17. The change in time is just our larger time number minus our smaller time number. It's just 30 minus 10, which gives us 20. And our rate then becomes 17 divided by 20, which is 0.85. Now here we have a question that again, it's just a sentence and we have to work out the rate. So during the first 20 seconds of a chemical reaction, 5 centimeters cubed of gas were given off. What is the average rate of reaction during the first 20 seconds? So you've got 4 answers and you have to work out which one is correct. The equation that you would use is change in quantity divided by change in time. Now 20 is 20 seconds, so that's our time. That means that 5.0 is our quantity. And 5 divided by 20 gives us 0.25 centimeters cubed per second. So our answer is D. And now we've got one final question. Might not be the easiest to see if you're watching this on a small screen, but you've got a graph and it is asking for the rate of reaction for the first 40 seconds. For this, for the first 40 seconds, what we do is we look at 40 seconds, we go up to the graph line and then we go across to the volume on the left-hand side. Our calculation is change in quantity divided by change in time, which is 72 for our change in quantity, and our change in time is 40, and that gives us a rate of 1.8 centimeters cubed per second. So that was a review of some of the past paper questions, examples of the types of questions and the approaches taken to do them. Hopefully at this stage you're feeling comfortable and confident in calculating rate, because that is us now finished all of the lessons for rates of reaction. So thank you for your attention during this set of lessons.